A rational expression is a quotient of two polynomials, which means that you divide two polynomials. So maybe you have a monomial divided by a monomial, like 2x divided by x. Or maybe you have a binomial on top, like 3x plus 1, and you divide it by a trinomial, like x squared plus 5x plus 6. That's what a rational expression looks like, something on top and something on the bottom. An undefined expression, remember yesterday when we did section 8.1 and we had error in the table? And that was when we had 0 in the denominator. You can't divide by 0. So if we had, for example, x over 2 minus 2, those 2's would cancel each other out and we'd have 0 on the bottom and it would be undefined. Or you could have something as simple as 27 over 0. That would be undefined. So let's look at simplifying these first expressions. It looks like we have a monomial on top and a monomial on the bottom. So we pretty much already learned how to do problems like these. 3 divided by 2 doesn't reduce, so that stays 3 on top and 2 on the bottom. And now we just look at the x's. We have 7 on top and 4 on the bottom. The rule is if we have 7 on the top and 4 on the bottom, they'll cancel out and you'd be left with 3 on the top. Or you could just do 7 minus 4 and get 3. So there's the answer. Let's do the same thing on B. First, let's simplify the numbers. 12 divided by 24 simplifies to 1 over 2. Next, we'll look at the x's. I have 6 on top and 4 on the bottom, so 6 minus 4 is 2, so it's x squared. Next, we will do the y's. So we have 1 on top and 1 on bottom, and so those two cancel right out. And last but not least, we have the z's. We have 4 on top and 5 on bottom. So when these cancel out, if we did 4 minus 5, we'd have -1, which means that the z's are on the bottom. So final answer without all those 1's would be x squared over 2z. On the last one, we need to deal with this a little bit differently because this x minus 5 is one whole quantity. So this factor doesn't match up with anything on the top because this is one big trinomial on top. But if we were to break the top into two factors, hopefully one of them being x minus 5, then we could perhaps cancel out the x minus 5 on the bottom. So I know in order to get x squared, I need to multiply x times x. And now I need to think of the factors of 10 that subtract to get -3. So factors of 10 to subtract to get -3. It looks like 2 and 5 will do the trick. The 2 needs to be positive and the 5 needs to be negative. So now that I factored the top, guess what happens? This x minus 5 and that x minus 5 cancel out, and your final answer is x plus 2. Now I just realized that I did the first step of all these problems, which was to simplify, but I need to also go back and identify any x values for which the expression is undefined. So let's look at the answer in 1a. See how there's a 2 on the bottom? There aren't any x's on the bottom there, so we don't care what x's make the expression undefined because there aren't any in the denominator. In 1b, we don't have x on the bottom, but see this z right here? we need to put a little disclaimer and write down the only number that z is not allowed to equal. And it's going to be a number that makes the entire bottom equal 0. Well, 2 times what equals 0? 0. So we'll put a little thing over here that says z cannot equal 0, because if it did, then the bottom would cancel out. And last, on 1c, if we look at this problem, see how it's x minus 5? Well, what if x equaled 5 to begin with? Then 5 minus 5 would be 0, and that wouldn't be good. So in this problem, x cannot equal 5. All right, there's many ways to do these problems, and it's honestly up to you which way you pick. So I'll do the first way in one color, and I'll do the second way in a different color. So we could look at these fractions if we were going to multiply them, and we might look at the 2 over 6 and say, hey, we can reduce that to 1 over 3, just make it smaller. And then we could look at the 8 over 10, and we realize we can divide both of those by 2 and reduce that to 4/5. So first I simplified, now I'm going to multiply. 1 times 4 is 4, 3 times 5 is 15, and I can't reduce 4 over 15, so that's my final answer. That would be one way to do it. Another way to do it is to just go ahead and multiply and then simplify. So let's just multiply right off the bat. 2 times 8 is 16. 6 times 10 is 60. So we multiplied first, but now we need to simplify it. What can we divide 16 and 60 both by? If we divide them both by 4, we'll get 4 over 15 for our final answer. So we got the same answer for both of these. It's just we did them both a different way. Now for 2a. Let's look at all these numbers and letters, and we're going to start simplifying as much as we possibly can. I can't simplify 2 over 3 or 15 over 8, but what I can do is simplify this 2 and this 8. So that's going to become 1, and that one will become 4. This way kind of drives some people nuts, but some people like simplifying it first. I know I can simplify the 3 and the 15. The 3 I can divide by 3, and that becomes a 1. And 15 divided by 3 becomes 5. So I just simplified all the numbers. And now you can see that on top, 1 times 5 is 5, and on the bottom, 1 times 4 is 4. So I've taken care of all the numbers. Now let's take care of all the x's. I have 4 right here, 2 right here, 3 right here, and 2 up there. I'm going to go ahead and look at this x squared and this x squared, and since one's on top and one's on bottom, just cancel them right out. And now all I have left to deal with is the x to the 4th and the x to the 3rd. 4 on top and 3 on bottom, 4 minus 3 leaves me with 1 on the top. Last, I just need to simplify the y's. I have 5 on top here and 2 on the bottom there, so 5 minus 2 is 3. So that's the final answer. Now I'll do that same problem by multiplying first and then dividing. So I need to rewrite the problem. So I'll do that first. I'll rewrite it. Actually, I won't rewrite it. I'll just go ahead and redo it. Let's pretend I didn't do any of that. Let's just go ahead and multiply everything to begin with. If you liked the first way I did that, it's fine. But now I'll do it a different way. So let's go ahead and say 2 times 15 is 30. By the way, we already know this is the final answer, so don't get this confused with that. All right. X to the 4th times x to the 2nd is x to the 6th, and y to the 5th times no more y's is y to the 5th. On bottom, 3 times 8 is 24. X to the second times x to the third is x to the fifth. And we have y to the second. Now I'm going to go through and reduce. What can I divide 30 and 24 both by? I can divide them both by 6. So I'll have 5 on top and 4 on bottom. What happens to these x's? 6 on top and 5 on the bottom. I'm left with 1 on top. And what happens with these y's? 5 on top, 2 on bottom. 5 minus 2 is 3. So you can see I ended up with the exact same answer. I'll do it both ways in letter B now as well. So first I'm going to simplify. So I'm going to look at all the numbers and figure out what I can reduce. It looks like I can reduce the 5 and 15. The 5 will cancel out to a 1. The 15 will cancel out to a 3. And 10 and 8, I can divide both of those by 2. So I'll be left with 5 and 4. So already on top, I know 1 times 5 is 5, and on bottom, 3 times 4 is 12. Now I'm going to deal with the letters. Let's see, I have x to the third and x to the third. Guess what? Those cancel out. Next, I have x to the second and x to the fifth. So that's going to leave me with 3 on the bottom, because 5 minus 2 is 3. It'll be down below. Now let's look at the y's. I have 10 right here, 9 right here, and 1 right here. So I'm going to look at this 10 and the 9. And 10 minus 9 leaves me with just 1. So this is y to the first. Y to the first and y to the first is y to the second. Last but not least, I'm going to deal with the z's. I have 1 on top and 1 on the bottom, and those are going to cancel out. So this is the final answer. Now I'll do that same problem by first multiplying everything together and then simplifying. So, we already know that's the final answer. Let me do this a different way. 5 times 10 is 50. X to the third times x to the second is x to the fifth. Y to the 10th times y to the first is y to the 11th, and then a z. Notice how I go in alphabetical order? All right, on the bottom, we have 15 times 8 is 120. X to the third times x to the fifth is x to the 8th. Y's, I just have 9. And then I have that z. Now I'll go through and cancel stuff out. So what can I divide 50 and 120 both by? I can divide them both by 10. Divide by 10, divide by 10. So on top we're left with 5, and on bottom we're left with 12. Next I'm going to cancel out these x's. I have 5 minus 8, which means I'll have 3 on the bottom. Now for the y's, I have 11 on top, 9 on bottom. 11 minus 9 is 2 on top, and those z's cancel out. So again, that's the same answer that we got the first way. In order to divide fractions, all you need to know how to do is multiply fractions, because in order to divide, you multiply by the reciprocal of the second fraction. So you leave the first one alone and you flip the second one over. So 1/2 stays 1/2. In order to divide it by 3/4, we are going to flip that 3/4 over and multiply by it. So we're going to multiply by 4/3. So 1 times 4 is 4. 2 times 3 is 6. And when we reduce that and divide both of them by 2, we get 2/3. So we're going to do the same process for these problems. I'm going to leave the first the first fraction, 4x to the third z over 9x to the second y. And I'm going to multiply it. I'm going to change that division sign to a multiplication by the reciprocal of this. So 9y to the fifth goes on top, and 16z goes on the bottom. Now this just becomes a problem like we just did. I'm going to go ahead and simplify everything first because I noticed some cool things are happening here. See this 9 and this 9? They cancel out. I know 4 and 16 will cancel out to 1/4. So I know I have 1 on top and 4 on bottom. Now let's deal with these letters. I'm going to find all the x's. I have 3 on top, 2 on bottom, and no more over there. So 3 minus 2 is 1. So I have x to the first on top. Now I'm going to look for all the y's. I have 1 right here on the bottom and 5 up here on the top. So 5 minus 1 is 4. Now I'll deal with the z's. I have 1 on top and 1 on bottom, and they cancel out. So that's the final answer. Done. Before I start the last one, I'm going to point out this hint, which is to make sure that the numerator and denominators are factored if possible. So when I look at this one up top, I see this trinomial with these plus signs. I need to break that down into 2 factors. So I'm going to rewrite it. Instead of x squared plus 7x plus 6, I know x times x is x squared. Now I need the factors of 6 that add up to 7. And positive 1 and positive 6 will do the trick, because 1 times 6 is 6, and 1 plus 6 is 7. So I've taken care of rewriting the first part. Now, since this is a division problem, I'm going to flip it over and multiply. So I'm going to multiply by 2y to the fifth on top over x plus 1 on the bottom. And remember that x plus 1, that all counts as one factor. So now let's look and see what we can cancel out. This x plus 1 on the bottom, that's going to cancel right out with that x plus 1 on the top. Now let's look for some other stuff we can cancel out. This 2 and 4, 2 on top, 4 on bottom, that reduces to 1/2. And I have some y's to cancel out. 5 on top and 1 on bottom will leave us with y to the fourth on top. So let's start writing the final answer here. I have y to the fourth. That's the only thing on top. And I have an x plus 6 right next to it. On the bottom, I have everything canceled out except for that 2. So you could leave your final answer like that, or you could distribute the y to the fourth, and your final answer would be x, y to the fourth, plus 6, y to the fourth, over 2. Now we're done. The last kind is solving equations. So now we have an equal sign in the middle. And the trick is just to get all the x's on the same side of the equal sign. So we have an x over here. We have an x over here in the denominator. Let's get it out of the denominator. To get rid of divide by x, we'll multiply by x, and it's gone. But we need to multiply this whole side by x, which means we need to distribute. X times x is x squared, and x times 2 is 2x. And all of this equals 35. Now we just need to keep going and solve it for x. I know that if I set this whole thing equal to 0, I'll be able to factor it. So I'm going to do just that. I'm going to minus 35 from both sides so that I can factor x squared plus 2x minus 35 equals 0. So I know that x times x is x squared, and I need to find the factors of 35 that subtract to get 2. Well, 5, and 7. It's going to be 5 and 7, but we'll have to make the 7 positive and the 5 negative so that 7 minus 5 is positive too. So those are the two factors, and now we just need to write down what x equals. We have x equals negative 7, and we have x equals positive 5. The only number that x cannot equal, remember how x was in the denominator up there? The only number it can't equal is 0. When we go to do problem 4b, I noticed something very interesting. I noticed that there's an x plus 4 on this side and an x plus 4 on that side. Since they're both being divided by x plus 4, why don't we just forget about dividing them both by x plus 4 and just deal with the top? So let's do that. Let's get these 8x's over on the other side with those 2x's. So 2 minus 8 is negative 6x. That equals 24. And when you divide both sides by negative 6, you get negative 4. However, if we go back and check our undefined values, let's see, what's the only value of x that would make the bottom equal 0? Negative 4, right? And we got negative 4 for the answer. So we have x equals negative 4 for the answer, and we have our undefined value, x cannot equal negative 4. So we can't have both of those for our answer, so the answer to this is no solution. All right, very last one. We have an x in the denominator on this side. Well, there aren't any other x's in sight, so why don't we just move that minus 1/4 over? We'll move it over by adding 1/4 to both sides. So those will cancel out, and we'll have 2 over x equals, okay, now we have to add fractions. We can't add 1/8 and 1/4 because they don't have the same denominator. But we can add 1/8 and, what do you do to 1/4 to make it into 8ths? Multiply on top and bottom by 2. So we're going to add on 2/8. So 1/8 and 2 more 8ths all together is 3/8. So that's what this equation equals. 2 over x equals 3/8. Now we can finish this up by cross multiplying. 3 times x is 3x. 2 times 8 is 16. And then you'll just divide both sides by 3 and get x equals 16 over 3, or you could write it as a decimal. The only number x is not allowed to equal is 0. So that's your one undefined value.